Hello all and welcome back. So in this video, let us continue our discussion on dynamic programming. And now let's understand what exactly is dynamic programming through an example. So if you all remember, we understood about recursion using a Fibonacci number code, right? So let me just write down the same thing. Fibonacci series. Now the series was defined something like this. Let's say the first number is 1, then 1. Then each and every next number is going to be equal to sum of previous two numbers, right? So it will be 3, then 5, 8, 13, and so on. Now, when we were doing this Fibonacci series, if all of you remember, the code which we wrote was something like this. So let's say if it is using recursion, something like this we used to do. So if my n is less than equal to say 1, then I can just return 1. Else I used to return fib recursive n minus 1 plus fib recursive n minus 2, right? So this was the way we were doing this particular question, where using the Fibonacci, using the recursion concept, we were able to solve this question very easily. But when we learned about the time and space complexity, there we saw that, let's say if I'm calculating the fifth Fibonacci number, so let me draw the tree as well here, then this is something which we followed, right? So minute, yeah, let's say if we start from 5, then each and everywhere we will have to make two calls. Let me just draw down the tree once so that it is a lot clearer. And as discussed in the last class, everyone, last video, that without recursion, understanding DP is not possible. So a very humble request that please make sure that you're spending a good amount of time on understanding what recursion actually is, how it works. We have done the same, and I'm really hopeful that you have not skipped that particular session or the section, right? So great, everyone. Now I think this can be the tree. Let me write down for 5. 5 is going to make call for 4, 4 to 3, 3 to 2, and then finally a call to 1 is also going to get made. Here this 2 is also going to make a call for 0, and in this way our tree used to get made. But something which we didn't realize at that time when we were understanding this in recursion is that 5 is going to make the call for 3 here, 3 is going to again make the call for 2, this 4 is going to make the call for 2 as well. So I am making a lot of multiple calls, right? So if we see in this particular example, even we have 2 called multiple times. So this is first, second, and third, right? In a similar way, if I move forward, a lots of number, they are going to get called multiple times in our this whole recursion tree, right? So this is going to now call for 1, and this is going to call for 0. In a similar manner, if we see for 1 I'm calling it a lot of time as well. So it is first, second, third, and fourth. So the basic thing which I want all of you to understand is that we are making a lots of duplicate calls, right everyone? So we are making a lots of duplicate calls, and because of that, what is happening is that I am not able to remember the solution and I have to make this call again and again and again. As our tree will grow more, you will see that each and every call is getting made multiple times. For example, here, one will be getting called 4 or 5 times, then two, let's say 3 times, three will be 2 times. Okay. But as we grow our tree, let's say for n is equals to 10, we will see that these calls will also increase with a great magnitude. If all of you remember the time complexity which we calculated, was somewhere around 2 to the power n time complexity of our recursion code, right? So it was around 2 to the power n. Now, the major problem in this particular time complexity is that yes, it is very bad, but if we just try to visualize or see the tree, you can be sure of one thing that we just want. Okay, so let me write this down. We are just making n plus 1 unique calls. What do I mean by that is I am making for n is equals to 0. Okay, so from 0 all the way to n. These are just the numbers which I am calculating. But since I am not storing their answer, I am calculating them again and again and thus making this complexity a lot bad. Right? So I just need to calculate these n plus 1 numbers. Right? But for that, I am trying to calculate them again and again, not storing the solution anywhere. And thus, the problem is that we are making it a lot more complex in terms of our time complexity. The same reason we saw that for n is equals to 50, it will never be giving us the answer. Okay. So let us try to see this a little bit more in code and the visualization. So let's go back to VS Code, everyone. Here, this is exactly the code which we talked about, just that I have taken the fib1 and fib2 as the variables. Let us have one thing here as well. So what we can have is a dictionary which is call, and every time we come here, all I have to do is if n, or let's say, so here we can check if n in my d1, oh sorry, calls, if it is present, then I have to say that okay, this is the first call. So calls of n equals 1. Else, what we can do, calls of n plus equals 1. So all I'm doing here is I am calculating that how many calls I am making for a particular number. Let us do one thing now. Fibonacci number, let's say of 5. And after that, let me just print the calls dictionary. And let us print the answer here as well. So I will repeat exactly what we have done, everyone. This whole code is just the code for calculating recursively a Fibonacci number. I have just added a dictionary to understand that, okay, for each number, how many calls am I making? Okay, so let me run this. Okay, so it's giving an error. It's saying that key error 5 is there. Okay, let us check that. Okay, so seems like yes, we have made a mistake here. So it should, if not in, then we should be adding it here. Else we should be improving, just increasing that. So let us run this again, everyone. See, so yeah, we are getting these calls. Let us see them in a little bit. Yeah. Okay, so it is giving me -5. That seems to be wrong. Let us correct this. We should return 1. Great, and it should be this. Now it will work fine. Great. So see this, everyone, now. What exactly is happening? For 5, I'm just making a 1 call. For 4, 1 call. For 3, 2 calls. For 2, we are making 3 calls. For 1, this is 5. The problem happens if I make it 10. And if I run this. Now, if you will see how the calls are increasing, right? See this now. So effectively, I will just repeat what we have done here. We are calling our Fibonacci number recursively. And I am just making sure that in this dictionary, I am maintaining that, okay, which is the number and how many calls we have made. So as to see that actually are we doing any repetitive work or not. Here it does seems like yes, we are doing a lot of repetitive work, as we can see in front of us with these calls. So one is getting called now 55 times, 2 34, 3 21. Okay. Just to make sure that we are able to understand the scale with which it increases, let me make it 15 and hope it gives us the answer. And now if you will see, Yes, 15 is just 1, 14 1, but see, 4 is getting called 144 times. 5 is getting called 89 times. But if you understand just one thing here, is that I am just calculating numbers. The calls are just being made for 0 till 15. Okay, so there are n plus 1 numbers which I have to calculate. So for n equals 15, I should just start from 0th Fibonacci number and go all the way till 15. And that is where, that is, sorry, all the numbers which we have to calculate. But because we are not saving the result, I have to calculate them so many times. And you can see how the scale has increased, right? Again, if I will do it 20, it will just blow out of proportion. We will be making so many useless calls which we could have avoided just if we saved our results. See, 1597 times 4 is getting called. Okay. Let us try to understand this via our visualization as well. So I found a very good overall resource for this. Now let me run this for Fibonacci 6, let's say, and let us run this. And we will see in front of us the whole tree getting made. See, the whole tree, the one way we made for recursion, right? It is just assuming that the first number is 0. We assume that to be 1, but that should be fine, right? So see, for 2, how many times we have to solve it? 2 again. So we are solving for 2 5 times. Similarly for 3, 1, 2, 3, 3 times. Okay. I hope you get the idea. All this is happening because we were not storing the result. If we would have somehow stored a result, let this code know that, hey, I have calculated for this number already. Please don't do that. Moving forward, we could have just avoided this thing. And this is the reason, if I maybe run it for 50, it's going to take maybe hours to complete, right? If I run this now, it's going to take a lot of time. Like for 50, it can happen that we can actually calculate that manually quickly, then waiting for this code to run. So we see this now that this code overall has a limitation. And that limitation is that because we are doing so much of repetitive work, we are not able to get our answer in optimized manner. If we take the assumption 2 to the power n calls we have to make, and we all know how big 2 to the power 50 can be, right? Great. So pretty sure now the problem is clear, everyone. And that is why I started DP with that quote that those who don't remember the past are condemned to repeat it. So because we are not remembering the past, that hey, if we have calculated this particular number or not, we are a lot more overall condemned that we are more likely to repeat that something which we are doing. Okay, so with that, I hope the basic idea behind DP is clear. Now let us see what all we have understood by this. So the major takeaway, everyone, is that we should somehow store the results for numbers we already have calculated Fibonacci for. Okay, Fibonacci or answer for. So the whole idea is that if you are able to calculate anything once, we should not be repeating the whole process, right? That is the whole major idea. Now let us move forward and see how can we do that. I think the easiest way for doing this is that we can maintain a list. We can maintain a list which stores the answer already calculated. Okay. So till now we have already seen that how maintaining a list, like what exactly list is and how that all can be used. Now what we all just be doing, we will be maintaining a list. Let us call that list diary. Okay. So let us now try to make a Fibonacci optimize. So diary, 1 minute. Yeah. Great. So minus 1, we have to just make sure that, yeah, into n plus 1. So let me take n as 5. Great. So what we are doing, everyone, exactly is that we are maintaining this diary where we will be storing our answer. Hopefully, before this code runs, we will be able to understand DP properly. Okay, great. Now let's see what's going to happen. Fibonacci with DP. Okay, and that is the whole process behind dynamic programming. Just that, hey, let us store our answer before you give it back. So the code is going to be the same majorly, but this time when you are returning it, this is in a way you have calculated this answer, right, everyone? So when you return it, after that, we can do our work, but it will be a little different this time. How it will be different? See, now I am storing this minus 1 here because I want a differentiator that if this was particularly calculated or not. Okay, let me zoom it out only. I'm storing minus 1 here because I want to have a differentiator that, hey, have I calculated this before or not? So see, let's say you ask me for Fibonacci of 5. I will just check if diary of n, which is your 5, if it is not equal to minus 1, that means I already have the answer and you can use this directly. So I can return this as it is. If that is not the case, and let us try to draw how our diary will look like. So pay attention, everyone. The way our diary is going to look is something like this. We will have 0, 1, 2, 3, 4, and 5. Now, when you want this 5, okay, I am just storing minus 1 everywhere. Now, when you come to 5, I first check if it is minus 1 or not. If it is not minus 1, then I can return you the answer because I am sure that this is going to be the answer. So that is why I have used minus 1 here. You can use 0 as well. 1 you cannot use. The reason is that 1 is answer for 0th and first Fibonacci number. Okay. Again, you have to choose a number which you are sure is not going to come ever in your answer. Similarly, you cannot use 10 or any other overall identifier for that, right? So minus 1 is a very good identifier because we know that our Fibonacci number cannot be negative as well. Now pay attention, everyone, what exactly are we going to do? This time again, I can just copy the code. I can copy this code again. Now, all I'm doing is when I calculate them, when I have this Fibonacci 1 and Fibonacci 2, I think it's a very good habit that I should store them as well in my diary. So let me just make it diary. Okay, because we have calculated, right? We have got the answer. We should be storing them in a diary again. So Fibonacci diary of n minus 2, Fibonacci 2. Now my answer is going to be Fib 1 plus Fib 2. I can return this answer. Very well, I can return this answer. Okay. Just one thing to focus here again, everyone, is that we should store this answer as well. If you have calculated this answer, right, it's always a good habit to store this answer as well. Because tomorrow, if someone comes to me again, hey, that you know 5, I should be having that answer, right? If that number is required again. Plus, when this will boil down to recursion, then we have to make sure that intermediate answer we are storing as well. Okay, let me just stop this, everyone. And now let's try to see few things. What if I am calling Fibonacci with DP? Let us call it for 5 first. Okay. And I'm able to get my answer. So this is 8. This calls we can remove as of now because we are not using that. So 1 second, one mistake. Yes. So we should just also do one thing. We should call this function now, not the other. Great. So we see that the answer we are able to get as 8. Okay. Great. Let us try to understand this a little bit in few multiple things. First, let us try to do this in Python tutor. Okay. Let me remove the different other functions And please make sure that you understand this very properly. There's a reason I'm making sure that I'm helping you visualize each and everything. Okay, let us remove every drawing. Yeah. Great. So pay attention, everyone. What exactly is going to happen? This is our whole code. Let me just edit this code and remove these extra spaces so that it is better overall to run. Let us now visualize. So pay attention. We make a diary and everything is -1 here. Then we go forward and define this function Fibonacci with dp. Then I'm calling Fibonacci with dp for 5. If you remember in the last video, I told that dp is just making sure that we are solving a subproblem once and storing their solution. And if you will see via this diary list, I have done the same thing. Once I solve the particular subproblem, then I will be storing that, right? And if required, I will just give you the answer from my diary only. Let us move forward now, everyone. It's getting called for n is equals to 5. Is n less than equal to 1? No. So let us move forward. Is diary of n not equal to -1? No, that is also not the case. So let us move forward again. Now you will see Fibonacci 1 getting called for n is equals to 4. Similarly, like this, I will be making these calls for 3, then 2, and finally for 1. When I make this call for 1, I have reached my base case. So I will be returning this 1. Okay. So 1 gets returned, everyone. You will see it here as well. When I return this 1, I have got Fibonacci 1. In a similar manner, I am going to call for 0 and I am going to get 1 here as well. Okay. So I will return 1 here as well because this is the base case. I have Fib1 and Fib2 and n is equals to 2. I can calculate my answer and see what all I am doing, everyone. Diary of n minus 1. N is 2 here. So diary of 1 becomes 1. Because I have calculated this answer, it makes a lot of sense for me to save it in my diary. Moving forward, diary of n minus 2 again, 0 is 1. And now I am calculating my answer. Answer is 2. And before returning this answer, I am storing this in my diary of n, which becomes 2. Diary of 2 is 2. Let us move forward. Great. Now this time, this 3, it made a call for Fibonacci of 1 and got the answer as 2. Next call it's going to make on Fibonacci of 2. So let's see that. Fibonacci with dp n is equals to 1. This is going to be a base case. We also have this stored in our diary, so it should be straightforward and we can return directly. Okay. So we got both the things and we can move forward. And if you will realize, we have done lots of steps for this n equals to 3, right? We made a call to 2, then we made a call to 1, then saved all these answers. Now I have got my answer. Answer Fibonacci 1 plus 2 is 3. What I have to do? I am storing this again, diary of 3. And I can move forward. Okay, great. Now this Fibonacci with dp, it got an answer for 3. Okay, it's going to make the next call for 2. Okay, but this time for 2, I don't have to make calls for 1 and 0. If you understand this, if we draw just the tree, right? So pay attention, everyone. 5 made a call on 4. 4 will be making a call on 3. 3 making a call on 2. Then 2 for 1 and 0. Every time I'm calculating an answer, I'm saving that as well, which you can see in this list. Now when this 3 is going to make a call on 1, I return because it's a base case. The real benefit happens here. When this 4 now is making this call to 2, I will go and check in my diary and directly return the answer. I don't have to make these calls moving forward. Okay. So again, just by adding 2-3 lines, I have saved my answer. And because I know that, hey, I have calculated this before, I am not going to calculate it again. That's the whole basic idea behind DP. It is taught in a very difficult way. I don't want you to ever be afraid of dynamic programming. It is just this way of doing the question. Majority cases, in 90% cases, if you are well versed with recursion code, you can easily transform that code into dynamic programming code. That is something which I have done right in front of you. Okay. And that's the basic idea behind solving DP questions. The better you know recursion, the better you will be able to solve DP questions. Now, if you will see, for N2, I will not be making many calls and I've just directly returned this. So I didn't even go to this level of code. Once I return this, I will be storing my answer. I have fib1 and fib2 for N4. Let me store this answer and you will see the answer here and go back. So we are at the highest level for N equals 5. We got fib1, which is 5. For fib2, okay, it is going to make the call for 3. Again, it would have made all these calls. Haven't we saved our answer? But being smart, using DP, we have made sure to save our answer. And thus, we can directly return the same, giving us Fibonacci 1 and Fibonacci 2 for n equals 5. Moving forward, we can just save everything, get the answer, save our answer, and finally return. And you have the answer. Okay, everyone. So we see 8 here. Now let us see the true power of DP. Well, the true power of DP is that if it is 50, 1 minute, let us make it 50 plus 1. Okay, if it is 50, we get our answer. And you can see how quick it is. Whereas for normal recursive approach, it will take ages to get your answer just because of the complexity involved. So again, I hope you are now able to understand that by just changing small things in our code, by just remembering our answer, we are able to write a fabulous code which is able to run very quickly. Okay. The basic idea remains the same, that let's save our answer. And now let me show you one more thing, which is the tree, because I want all of you to understand and respect everything. Understand and properly have the intuition for everything. Okay. So see, I'm just turning on this memoization. So this whole process of adding the memory, of adding the diary into your code, that is what is known as memoization. Moving forward, instead of diary, you will see me making a memo as a list. Okay. So this way of solving is known as memoization. The way I remember it, having a memory in your code. Okay. In a way, this diary is a memory. This is helping us not to forget the past. And if we just run this now, and this website I will share with all of you, see what's going to happen. Call made to 654321. Now you will see that we will not be making calls except for base case. Multiple calls will not be made. See, 2, it get for 0 and 1, we save the answer. Then 3, 2 and 1, we got the answer. 4, it called for 3, okay, and for 2. But 2 is not calling downwards because we have this answer saved from here, right? Let me just explain you pretty nicely. So pay attention, everyone. So what is happening here? See, 6 made this call to 5, 5 to 4, 4, 3, 2, and 1. Let us make a diary or memo list here. 0, 1, 2, 3, 4, 5, and 6. Right? Now see what exactly is happening. For 1, we are calculating and we know the answer is 1, so we stored that. For 0, it is 0, so we stored that as well. Now for 2, we are returning the answer as 1 and we store this. 3, when it makes the call to 1, it's actually a base case, plus we have it saved in our diary as well. So we can return and say that, hey, 3 answer is 2, as you see here. Now when this 4 has to make a call for 2, okay, for fib2, that is n minus 2, we just directly go to our diary. We are not doing this many work, right, everyone? And we get the answer. So 4 can return 3 as an answer. Now, when this 5, it has to get for 3, because it has already received the answer for 4. Next will be fib2. 3 is not going to do all these work. No, it has this answer, so it is just directly going to return true here and we will get 5 here. Now next call, this 6 is going to make for 4, which is the fib 2. Fib 1 it has already made. This time, instead of doing all these work, right, all these work which 4 did initially, it will just directly return the answer. As we can see, directly 3 is returned. No such tree is made. And the reason is that we remember the past. We know that, hey, previously I have done this kind of a calculation, so I don't think I need to do it again, right? We saw the same thing in Python tutor as well. Here also, by a tree, it is also clear to you properly. And you can see how many calls are getting overall eliminated by this approach. And thus, how DP is very good concept of solving your problem, right? So now once I have got for 6, I can directly say 8 is my answer. Very comfortably, I can say that if I add this function returns 8. Okay, everyone. So I'm pretty sure that this whole approach now will be a lot more clear. Again, we are going to talk a lot. DP is all about solving problems and understanding different approaches, something which we are going to do as we move forward. But the basic idea should be a lot clear. And that is the exact reason I am using so much visualization, doing each and everything in front of you so that you understand the basic idea. Okay. So now what I want all of you to do is to make this Fibonacci code, see how many repetitive calls we are making. Write this code once yourself using this diary, or even just write it in front of you to see if you have actually calculated for that number or not. Try to use Python tutor to see how your diary, this list is getting changed, and you will get a whole idea. So the exact same thing which I have taught you, just take 15 minutes and try to do this at your end once. Okay. So that's the very basic idea, everyone. I am now pretty sure that DP, the idea is clear. Again, it will get a lot more clear as we do more and more question, something which we will be following in the upcoming videos.